Hello, good evening. All right, we'll continue the next part, chapter 7. This is probability. All right, now as what you have seen earlier on, the concept of probability is when we actually make a opening, not sure, it might not happen. Okay, so under probability, there are a few terms that we actually need to know, or rather, we already know. Okay, basically, you must know what's an experiment. We all know what experiments are. All right, next is sample space. Okay, the listing of all the outcomes, and of course the event will be a specific condition, or a specific a value. It can be a value, or it actually can be a consequence of something happening from the sample space. Right? Okay, so we take an example. Now let's say we have got our condition, or rather our scenario here is a fair dice is rolled once. Okay, so usually we use the word fair. Fair means your dice is not biased. All right, so your sample space, now sample space is normally denoted with S, capital S, open, you've got braces. So these are your possible outcomes. You've got 1, 2, 3, 4, 5, and 6. So this is the outcomes that you might get when you actually roll dice. Okay, now here N, this N stands for the number of elements in this set of S, which is this. So how many outcomes do I have? 1, 2, 3, 4, 5, and 6. So this is 6. Okay, all right, next, let's say E. Okay, I denote E as the event of obtaining even numbers. So for even numbers, we're actually going to pick from the outcomes of your sample space. So even numbers is going to be 2, 4, and 6. So the number of elements of event E is actually 3, because I've got 1, 2, and 3. Okay, so this is your number of elements in set E. So I've got 1, 2, and 3. So now they want us to determine, let's say, determine the probability of obtaining even numbers. So this is a formula that the formula for probability, which you have seen earlier. All right, so the probability of event E is actually the number of elements in event E over the number of elements in your sample space. Okay, so this is what is required. So if you want to find the probability, so the number of elements in E is actually 3 over NS. This is my NS, which is 6. So 3 over 6. So when you actually simplify, it actually becomes half. Okay, so this is one formula that we actually need to know on how to get your probability of certain events that we want to look at. All right, okay, next we move on to one more example. Okay, so now let's say I've got a coin. A coin is randomly picked from a boxer, okay, with different denominations. So I've got 1, 5, 10, 20, and 50 cents. So now, as what we have seen earlier, if you want to list down your sample space, the outcomes that you might get in your sample space, you can pick 1 cent, you can pick 5, you can pick 10, 20, or 50. Okay, so all you've got 1, 2, 3, 4, 5. 5 outcomes in your sample space. So now for A, so they want you to find the probability of selecting the denominations which is more than 10 cents. Okay, so the probability of more than 10 cents. Okay, so if it's more than 10 cents means this is considered my event specific from this general sample space. So if it's more than 10 means I'm going to pick 20 and 50. So meaning I've got 1 and 2. This is 2 out of 5 outcomes. Okay, so that's my probability. Let's say for B, you want to pick more than 50 cents. Okay, the probability of obtaining more than 50 cents. Okay, so if it's more than 50, the highest denomination here is actually 50. So if it's more than 50 means there's no outcomes. So it actually be 0. Okay, so for any probability that we are looking at, all right, now probability is always in the range of 0 to 1. So meaning it's always a positive value, nothing less than 1 and nothing more than. So the maximum is only 1. Okay, all right. Okay, so we take one more example. Okay, what happens if, so here we actually looked at probability of one situation happening. All right, so what happens now is, what if you have 2 events, okay, happening? All right, so we take one example. Now let's say a class has 30 students. Okay, out of these 30 students, okay, 22 of them are actually members of the chess club. All right, so I've got 30 all in. This is only 22, and I've got 20 students who are actually members of the Leo club. All right, so for A, they want us to draw a Venn diagram to represent, okay, the above conditions. And B, find the probability of students who are members of both clubs. All right, so basically this is how the whole thing goes. It's just a simple diagram. Okay, now let's say I've got 30 students. Out of the 30 students, I've got 22 students who are actually members of the chess club and 20 students who are actually members of the Leo club. So now, if when you add up 22 and 20, this sums up to about 42 students. But I only have 30 students in the class. So meaning, if I have this, right? So this is 42. So 42, that means I have an excess of 12 students. So meaning these 12 students have been calculated twice, whereby they actually belong to both the clubs. Okay, so if you are going to draw, or you're going to draw a Venn diagram, so what you'll actually do is, let's say C represents your chess club and your L represents the Leo club. So C represents chess club and your L represents the Leo club. Okay, all right, so what you'll actually do is, since this 12 is actually counted twice, and that's how we got this excess of 12, so the 12 is here. All right, okay, now out of this 12, they say 22 students are actually members of the chess club. So this is my chess club. I've got 22 members all in. I've already got 12 here. So what is the remainder is 10. So 10 and 12 will actually make up to 22 members. And likewise for your Leo club, altogether I've got 20. So there's already 12 here, sorry. So this will be 8. So this is how your Venn diagram would look like. So we do not have to have that rectangle outside that represents the universal set. Here, why? Because here the total is only 30 members and all of them are actually members of these two clubs. So there's nobody outside the chess or the Leo club. Okay, all right. So for part B, so this is your Venn diagram. So students who are actually members of both the clubs. So find the probability of students who are members of both the club. So members of both the club will be 12 out of 30 students. Okay, so when we simplify this, you'll actually get, you can actually get what? This is 3, 4, and 10, which can be 2 over 5. Okay, so that's your probability. All right. Okay. One more concept. Okay, the probability of a mutually exclusive event. Okay, the concept of mutually exclusive. What's the meaning of that? All right. Now, when you're talking about this term, mutually exclusive, it actually relates to two events. Okay, two events that does not happen at the same time. Meaning, if you have event A and event B, okay, what happens to event A and event B? So event A and event B does not influence each other. So they actually stand alone. All right. Okay. And you have got one more word, exhaustive. Okay, exhaustive means when you actually list down, okay, let's say your two events are A and B. Yeah? So when you list down the events, the outcomes of event A, and you list down the outcomes of event B, all right? When you actually put the outcomes together, it will actually result in the outcomes. That means the number of outcomes in your sample space. Okay, so that's what it means. Huh? So for an example, so exhaustive is example. Now let's say I've got, this is my sample space. I've got numbers ranging from 1 up to 10. Okay, then this is my event A. This looks like my odd numbers 1, 3, 5, 7, and 9, and my even numbers 2, 4, 6, 8, and 10. All right. Okay, so now if you notice, event A and event B, they're actually different. All right, they're actually different. That means the elements that we actually pick or the outcomes that we obtain in event A is entirely different from event B. Okay, so this is what it means, and they do not influence each other. Outcomes are all different and they do not happen at the same time. All right. Okay, so what happens is when you actually put event A and event B together, so this is the symbol of union. Okay, the symbol of union means you're actually, all right, gathering all of A and all of B together. So what happens is when you actually list down, A is 1, 3, 5, 7, 9, and B is 2, 4, 6, 8, 10. So actually when you list them up together, you realize that this is actually the same as your sample space. All right, so for your sample space, if it's the same, this is considered exhaustive. Okay, this concept here is considered exhaustive. So that means if two events are mutually exclusive, is to be said to be mutually exclusive, I can say that the probability of event A and B together is actually the probability of event A plus the probability of event B. Okay, so when you actually want to draw out your Venn diagram, okay, it will actually look like this. Okay, there's no intersection, and when you add up the outcomes, it will actually result in the outcomes of your sample space. Okay, compared to what we saw earlier, this one that we saw earlier, all right, the probability of two events, this is also two event, mutually exclusive. The one that we saw just now is also two event. But the difference here is, you see, there is an intersection of 12. Here, there is no intersection. So for mutually exclusive, okay, this formula can be used. Okay, if you have cases like this, okay, whereby you actually have an intersection. So for this, we can actually write A union B equals to the probability of event A plus the probability of event B minus the probability of A intersection event B. Okay, so this is the difference. All right, this is the difference between this example, okay, and this example. All right, so for this example, it's mutually exclusive. and it's exhaustive. All right. For this, it's not, okay, because one will actually influence the other event. All right. Okay. So we'll continue a little bit more, all right, in the next video. Thank you.